Most people think the power grid is a smooth, modern machine that quietly delivers electricity to every home and business in the country. But behind the scenes is a single, aging piece of hardware that the entire system depends on. A bottleneck so deep that regulators, utilities, and insurers are quietly calling it one of the biggest economic risks in the United States. And almost nobody outside the industry knows it exists. It's the high voltage transformer. These transformers are the backbone of the grid. They're huge steel giants, some the size of a small house and weighing over 400,000 pounds. They take raw electricity from power plants and step it up or down so the grid can actually use it. If one of these fails, there is no quick workaround. The grid doesn't reroute gracefully. It strains, overloads, and forces utilities into expensive emergency maneuvers. Here's the part that matters. The United States has thousands of these transformers, and most of them are old. Not a little old. Many were built in the 1970s and 1980s and are now pushing 50 years of service. They were never designed to last this long, and they're being pushed harder every year by record heat, record demand, data centers, electric vehicles, and a grid that was never built for this kind of load. When a transformer fails, it's not like a local power line going down. Utilities must scramble to buy emergency power at inflated spot market prices. Factories shut down, hospitals switch to backup generators, and if the failure happens during extreme heat or deep cold, the strain on the remaining transformers can trigger cascading stress across the region. So why not just replace them? Because you can't. Only a handful of factories in the entire world are capable of building the large, high-voltage transformers the U.S. needs. Lead times aren't weeks or months, they're 18 to 36 months, and sometimes longer. There's a global shortage of the specialized electrical steel needed to make their cores. There's a shortage of engineers who know how to design them. There's even a shortage of trucks and rail cars strong enough to move them. This isn't a hypothetical problem. Utilities across the country are already reporting multi-year delays for replacements. Insurance companies have raised premiums because transformer failures are becoming more expensive. And grid operators warn that rising demand from AI data centers and electrification is accelerating the stress on equipment that's already past its expected lifespan. The real risk isn't that the United States is one transformer away from a catastrophic grid collapse. That's not how the system works. The real risk is the supply chain. A fragile, slow, global pipeline that can't keep up with the pace of aging infrastructure. If multiple transformers in a region fail during peak demand, the grid doesn't fall apart, but it does become expensive, unstable, and vulnerable. Utilities are forced into costly emergency purchases, prices spike, factories cut hours, and the economic impact spreads far faster than most people realize. This is the hidden cost of the modern energy economy. The technologies shaping the future, AI, manufacturing, electrified transportation, all demand more power than the grid was ever built to handle. And the hardware needed to upgrade that grid moves slower than the industries relying on it. The future runs on electricity, and electricity runs on a global transformer supply chain that's stretched thinner every year. It's one of the quietest, most important economic bottlenecks in America, and the world is only just beginning to feel it. Thanks for watching. If you want more breakdowns like this, make sure you're subscribed. I'll see you in the next one.